Looking back at the history of humanity, we see that many of the great contributors in our understanding of the universe were polymaths. Aristotle, Leonardo da Vinci, Leibniz and Lomonosov are just a few examples. But around the great scientific revolutions, our knowledge expanded fast, which pushed people of science to distinguish between different fields of study and often tightly specialize in one of them. Different sciences developed different languages and frameworks, and while great advances in our understanding of natural laws were present, the separation also acted on our intuitive look at reality. Many people started separating different categories of our universe, and the search for connection between them was put on hold. In the past century, we observed an exponential growth in technology. It spread fastly in all kinds of scientific studies, allowing them to search for experimental proof of new theories. Experimental physicists developed huge colliders. Biologists created imaging techniques that gave them a deeper view of the workings of an organism. Computer scientists gave the world a tool to simulate and manipulate huge chunks of data, thus catalyzing the breakthroughs needed for what comes next. The freedom we get when we follow the trace of technology allows us again to focus on unification of all the knowledge we have gained. This is not to say we are anywhere near full understanding, but now we see how the universe is an entanglement between different levels, scales, and frameworks. The lecture that was later turned into a book, What is Life? By Erwin Schrödinger, is a great example of this unification. He is regarded as one of the fathers of quantum mechanics and tried to answer the question: how can the events in space and time, which take place within the spatial boundary of a living organism, be accounted for by physics and chemistry? Besides the obvious influence the book had on genetics, by analyzing DNA as the heredity molecule, Schrödinger also took an interesting approach by analyzing biology from first principles. He fused biology and physics and attempted to explain how biological organisms defy the second law of thermodynamics, that the entropy or the chaos of a system always increases. I think, in a way, there is no object more unifying to sciences than the brain and its inner workings. After all, what we know about any discipline is contained in our model of the world, which the brain creates. This is a problem of understanding what is to understand. Another reason for the mystery around consciousness is that it sits at the top of the scales of disciplines. When we build the world from the most fundamental principles of physics, we move higher to chemistry and biology, and after that come all products of the brain, such as psychology, economics, sociology, politics, abstract and art studies. The brain both plays by the rules of natural laws and creates a whole new subjective world, far more eluding and complex than the movement of one pair of atoms. Consciousness, just as other fields, has to be approached both theoretically and experimentally. The theoretical part connects mechanisms from physics, neurobiology, and psychoanalysis as a few examples. Imaging tools are used to develop a map of the psychotemporal structure of the brain. Of course, all that has to be paired with the subjective world that we all experience on a daily basis. The challenge in this task is the nature of subjectiveness to explain in formal or even informal language. People struggle to put sensations into words. Colors cannot be imagined by a blind person, no matter how much you try to describe them. There is something besides knowledge, something that comes only from experiencing a subjective point of view. To make things even more complicated, we have, in a way, found consciousness to be somewhat unstable system. By unstable, I mean not concretely defined by a certain specific state. We have distinguished between several conscious states that vary radically in their subjective qualities. The normal waking consciousness of an adult is just one state. Coma, sleeping, and infant consciousness are different states, but nonetheless, we say they possess some qualities of conscious experience. And to bring some controversy into the equation, we should also aim to explain the uniqueness of the psychedelic state. Not just as a mere way to enter intriguing perception changes, but also as a tool to gain scientific insight into the strange world of subjectivity. So I want to tell you about a theory of conscious states that combines the theoretical worlds of physics and neuroscience through neuroimaging research with psychedelic drugs. The entropic brain theory was first proposed in a paper by Professor Robin Carhart Harris in 2014 and tried to answer questions such as how does the normal waking consciousness of healthy adult humans relate to other states of consciousness? How does the human brain maintain its normal state of waking consciousness? And what happens to the human brain's functionality when non-ordinary states such as rapid eye movement, sleep, dreaming, early psychosis, and the psychedelic state occur? Those are some challenging questions that go to even deeper unknowns, like the relations of informational, mechanistic, and qualitative processes. In the paper, it is said that at its core, the entropic brain hypothesis proposes that the quality of any conscious experience depends on the system's entropy, measured via key parameters of brain function. In simpler words, a key factor of the subjective characteristics of a conscious system will be its entropy. Entropy has spread into many different fields, and for that, it has explanations through many different perspectives. In our everyday life, we encounter entropy with every second that goes by. Our rooms get messier, leftover food disintegrates. Even when you stir your coffee and milk in the morning, you create chaos. So what is entropy? Shortly, we say it is a measure of the disorder or randomness of a system. The randomness of a system is tightly intertwined with its informational characteristics, or our uncertainty about the system's state if we were to sample it at any given moment. A classic example could be the states of matter. An ice cube has tightly packed H2O molecules, which have very little room to jiggle, and therefore the randomness of the system is low. In the gas state of water, however, the particles are loosely bound to each other and have high freedom for movement. If we were to try to predict the state of a gas system at a given moment, we would find it way more challenging than with other states of matter, as statistically there are more states in which each individual unit of the system could be in the next moment. Entropy increases as the gas spreads out in space, creating even more possibilities. Moreover, in entropic brain theory, we see a unique correlation between the entropy of a system and the subjective uncertainty or surprise of a system, as uncertainty increases with entropy. This is consistent with the Carl Friston free energy principle, for which we have briefly covered in another lecture and deserves a whole mix for itself. In our lives, we may often think we walk on the line between order and disorder. In systems entropy, this is the idea of self-organizing criticality. It refers to how systems with many units that show emergent properties exhibit unique properties when operating in a critical zone just between order and chaos. In recent years, growing evidence is surfacing that the brain may be one such complex system. So we immediately start to encounter questions about the relation of criticality with the workings of consciousness and the human mind. The paper also explores metapsychological concepts such as the ego or the self. All of this is elegantly put together under a common roof with the assistance of the experimental and empirical implications of the psychedelic state. So, what is found to be so scientifically unique about the psychedelic state is that through recent neuroimaging research with the psychedelic drug psilocybin, we discovered that it is a state in which the brain exhibits higher entropy than that of a normal adult. This should catch your attention because earlier we said that the brain operates in a narrow critical point between too much and too little entropy. So how come you can increase the entropy with those psychedelic substances? The answer which the theory proposes is that the human brain of modern adult humans operates in a slightly subcritical state, unlike the ones of other animals, including our closest antecedents. What is found to be the abstract projection of this heightened ability for entropy suppression in the brain is the creation of the mature ego. So here we have to clear an intuitive confusion that might arise from the last few implications that I talked about. The official paper explains the view taken is that humans do exhibit higher entropy than other animals, and therefore possess a higher number of possible states for the brain to occupy. So it's not entropy suppression that is the defining quality of human evolution. The proposition is that the evolution of the human mind developed during a period of entropy expansion and is now in the period of entropy suppression, where the system reorganizes and settles after the turbulence. A key insight of the theory is that during early human evolution, we were in an elevated state of disorder, as are human children during infancy. So in a way, we are moving away from the expansion phase and into the settling phase. In the original paper, the topic is continued with meta-analysis of the value of psychedelics in consciousness studies, but a lot is being said and will be said on that topic in future years, so we will just jump right into the facts and mechanisms of psychedelic pharmacology and neuroscience. This topic also deserves its own time, but brief simplified explanation is also worth mentioning in this video. The brain is made up of neurons, which are connected to other neurons and communicate with electrical impulses. This electrical communication is supported by receptors and molecules called neurotransmitters. Those chemicals act on the neuron as a messenger, who makes the neuron more or less likely to send an impulse. Classical psychedelics act on the 5-HT2A receptor, which usually takes in serotonin. Through a series of imaging research with MRI and MEG that are both ways to observe the brain on a deeper level, evidence is showing that psychedelics depolarize certain neurons, biggest group being layer 5 pyramidal neurons, which are the primary output neurons from cortical regions, and making them more likely to fire. Even though none of the studies directly measured entropy in the brain, the elevated ability of neurons to fire will make them statistically unpredictable, and random, therefore implying elevation of entropy. So we have the implications for entropy, but how this is translated into subjective experience can be investigated with the research of a mysterious network in the brain, namely the default mode network. The DMN is proposed to be related to the emergence of the sense of self. We can also practically see the importance. The posterior cingulate cortex, or PCC, is a prominent part of the default mode network and indeed receives 40% higher blood flow and metabolic rate than the rest of the brain. This is a suspiciously big amount of energy going into a single network, so it's no wonder it has caught the attention of neuroscientists. The densely connected DMN serves as an information router, and within it, the PCC is functionally connected to many regions of the brain. And while those networks are relatively separated from sensory processing, they play the role of a guide for the global brain activity. The central connectivity is unique to the default mode network, and it is consistent with experimental results that it sits at the top of the hierarchy of the brain. Professor Markus Reichle describes the DMN for the brain as the dark energy is for cosmology. We know it relates to higher metacognitive abilities such as self-reflection and mental time travel. We also know that its connectivity increases from infancy to adulthood, as well that it went through significant expansions during the course of human evolution. However, we have a poor understanding of the nature and high energy consumption of this network. During imaging with psilocybin, researchers measured blood oxygen levels, cerebral blood flow, functional connectivity, and oscillatory power of certain systems of the brain. They observed a decrease of those things within systems that are usually highly organized, connected, and metabolically active. Think about the possible implications for a moment, and as we dive deeper into the theory, you can refine your reasoning. A novel differentiation that the theory proposes is that between what they call primary and secondary consciousness. The states that are primary and pre-ego are, for example, that of early psychosis, dreamy state, the psychedelic state. They are related to decreased ability for correct prediction of the environment and increased vulnerability to biases, them being emotional or instinctive. The normal human waking consciousness is a secondary state. It is more organized and synchronized, with elevated ability to self-reflect and predict the environment. Prediction is actually thought to be fundamental for the workings of the brain. This is again consistent with the free energy principle. The secondary state is a state tuned for creating a precise model of the world, for prediction based on that model, and error correction of that prediction. To survive, the brain has to minimize what it does not know. It has to minimize the thing with many names: surprise, uncertainty, or just entropy. A key proposed insight is that for a secondary state to be turned into a primary state, the brain must undergo a phase transition. This is what happened during early human evolution, when we went through rapid development of metacognitive abilities, such as the ego. For such a metacognitive abilities to occur, it is argued that the brain must have developed the ability to operate slightly below the critical point between order and chaos. By suppressing entropy, the modern human mind in a way constrains its cognition, which allows it to organize. And when it organizes, it becomes better at prediction. Primary states may be more flexible because of their low organization, but secondary states carefully sample the world and learn from their past experiences. The impressive result of that learning and entropy suppression is all the technology, culture, and infrastructure we see around us every day. Without getting too technical, one of the propositions in the theory is the importance of coupling between a part of the brain called the medial temporal lobe, or MTL, and the default mode network, or DMN. They theorize that decreased coupling between those networks underlies phase transitions to primary consciousness. The results of an fMRI imaging investigation with psilocybin, which as mentioned leads to primary states, showed decreases in function coupling between MTL and DMN, and increase in variance of both signal fluctuations in the hippocampus. This is consistent with the idea that this coupling is needed to support waking adult consciousness, and its absence is needed to shift to primary states. We already mentioned those special layer 5 pyramidal neurons. They are special because they are densely covered in 5-HT2A receptors. If you don't remember, those are serotonin receptors and are the main target of classical psychedelics. The layer 5 cells are observed to fire with increasing alpha frequencies. You have probably heard of those alpha, beta, gamma, delta brainwaves and frequencies. Brainwaves emerge from synchronized pulsing from masses of neurons and are usually indicators of certain subjective states for the individual. Self-reflection is found to be related to alpha power, and alpha synchronization to be related to the blood oxygen levels of the DMN. Thus, The DMN is again connected to introspective process. It even has inverse networks that are usually active during executing external tasks. This is the task-positive networks that are inactive during DMN self-reflection, but active when interacting with the environment. Alpha oscillations, just like the DMN, mature both during evolution and development. It is theorized that those rhythms play a critical role in entropy suppression. This is done by increasing the mutual information among groups of neurons. Keeping in mind the organizational power of brain rhythms, it is remarkable what the researchers observed when imaging the psychedelic state. They found a strong positive correlation between the decrease of alpha power in the PCC, which again is a central node in the default mode network, after ingestion of psilocybin, and the rate of participants reporting ego death, which refers to the disintegration of the self. So, to unify these findings, we can say that when the default mode network is in a state of increased entropy, which psychedelics cause, the hold of the sense of self on our subjective reality is weakened. The pre-ego state is the primary state, which critically floats in heightened entropy, and may be close to what infants, animals, and certain mentally ill patients experience. So, just as we can observe decrease in activity and connectivity of the default mode network in primary states, we can also observe the opposite. When we experience mental time travel and introspection, the DMN shows more activity. But if we take that to the next level, the DMN becomes hyperactive and depression starts to occur. For a simple explanation, you can imagine how the more you reflect on yourself, the more connections are made in that hub of the brain. The connections between the neurons may become so strong that they in a way create a closed circuit where the signals start to loop. This may be the physical reflection of the negative thought loop that is observed in people with depression. To make the role of the organized DMN in metacognition even more clear, we can observe its inverse coupling with task-positive networks. When we concentrate on an external task, self-introspection is decreased, so your attention can be mobilized into said task. Remarkably, in people with ADHD, or attention deficit hyperactivity disorder, the inverse coupling of DMN and TPN is decreased. This means the connections in the brain allowing for internal wandering to occupy the individual's attention when they are trying to focus on an external task. This is clearly seen when we observe the ability of people with attention deficit to ignore distractions. The challenges are not only mental, but also wired in the physical layer. It is widely thought that the brain is a self-organizing system with stable configurations on the temporal and spatial scales. The stability can be disintegrated up to a certain point, and this is of course the point of critical entropy. When observing a dynamical system, such as the brain, we measure entropy by quantifying the variations of intrinsic synchrony over time. The variance of a network is simply a statistical concept, which describes how many signals deviate from the mean signal and by how much. You see this kind of thing every day. For example, you could measure the mean of your food intake to, let's say, mostly vegetables. So you could track the variance of your diet by measuring how often you eat something different, as well as how different it is than the usual intake. In this example, you will have a highly statistically varying diet if you eat many different foods at different times. While if you only eat veggies every day, you have a statistically low deviation from the mean and therefore have a highly unvarying diet. So, in the psilocybin fMRI experiment, researchers observed what happens to the variance of intra-network synchronicity in 9 key networks. They found significant increase in the network variance over time in higher level networks, but not in sensory-specific and motor regions. So, under psilocybin, higher cognition networks destabilize their internal organization. If not already clear, this is experimentally consistent with entropic brain theory. Through a series of processes, researchers analyzed the variance of synchronicity and translated it into the more known measure of randomness, Shannon entropy. Expectedly, higher cognition networks exhibited unquestionably elevated entropy in the psychedelic state. Normally, there is nothing of which we are more certain than the feeling of ourself, of our own ego. This is a quote from Sigmund Freud cited in the paper. It simplistically describes how even when relatively inactive, the default mode network never really stops receiving blood flow and information from external drivers, such as the MTO. It means, during normal human conscious state, you never really forget that you are someone. The ego, or individuality, always sits behind as the silent guider. Well, not always, because it's silence in the primary state, which might be a suboptimal style of cognition that humans have abolished for the more reality-bound secondary state. So now, we have to understand why, even though the primary state is a less efficient style of cognition, first-person reports consistently described being profoundly affected, often in a positive way, by the psychedelic experience. The clue to understanding the impact of psychedelics may actually lie in our knowledge of depression. The depressive state is characterized by the inability of the affected to escape certain patterns of self-reflection and criticism. The style of cognition in patients with depression is highly inflexible. Thus, they possess a lower repertoire of transitional states that the system can enter. This repetitiveness of signals is also seen in patients with OCD and addiction. When your brain enters a closed state, such as craving in addiction, the more flexible the network is, the more likely it will escape from the loop. The theory proposes that in primary consciousness, the substates of the brain are less stable. This means that the brain has a higher repertoire of states it can enter because it is closer to the critical point of entropy. In the entropic brain theory, the therapeutic potential of psychedelics is openly discussed. They are interested in the mechanisms that make the brain behave differently. They describe how psychedelics disrupt stagnated patterns of thought by disintegrating the patterns of activity upon which they rest. Even though the brain of the modern human adult is thought to operate on slightly subcriticality, a problem occurs when pathologically subcritical styles of thought emerge. This is when we observe the inflexible states of OCD and depression. Psychedelics increase entropy and may normalize such patterns. They are the counteractors of overly organized states. The subcritical brain must have a reason for putting that much energy into organization and entropy suppression. One reason may be that it increases the ability of the brain to sample and manipulate the natural world, most of which is actually critical. After all, you need to be more ordered than what you wish to control. The theory even proposes a beautiful reason for why people often consider themselves in more harmony with nature during a psychedelic experience. By increasing its entropy, the brain literally becomes closer to the critical state of nature. In this paper, it is clearly said, however, that the therapeutic potential of psychedelics is the most risk-free when the experience is mediated by appropriate therapeutic care. Both the neuroscientific and psychoanalytic studies with psychedelics are currently waking up from a long government-enforced nap, and the full scientific implications will be met along the way. All this must be considered only a brief introduction to the entropic brain theory, as just the main topics are covered and much more is left to explore by the curious listener. To summarize our journey through entropy, the following report might be useful. The brain of people in the psychedelic state, lesser animals, people with psychosis and infants, is an example of a more primitive style of cognition known as primary consciousness. This brain operates on a critical point between order and chaos, and while it is more flexible than the adult human brain, it lacks a certain ability to sample and predict the world accurately. At some point during early human evolution, our species experienced a rapid expansion of entropy in the brain, which allowed us to access a higher repertoire of mental states. And while in the beginning of human evolution, as in the beginning of human development, we were expanding our entropy, what really gave us the advantage was the settling into a slightly subcritical state of entropy. By suppressing chaos, the brain was able to organize into a highly connected and synchronous network, from which brain hubs such as the DMN emerged. The default mode network is responsible for the sense of self and the style of cognition that is governed by the ego, also known as secondary consciousness. The main difference between the primary and secondary state is the quantity of entropy, and that a phase transition is needed to transform one into the other. Imaging research with psychedelics found evidence for the correlation of entropy and the self, and also proposed physical mechanisms within the brain that are responsible for a number of conscious experiences. So, now that you know about the foundational importance of entropy in the miracle of life, I would like to hold your attention for a few more minutes so we can explore some possible implications, even beyond what is mentioned in the theory. It all starts with the observation that entropy is fundamental to life. Organisms defy the second law of thermodynamics, and we could scan the cosmos for structures that show signs of internal organization and label the findings as life or its artifacts. Furthermore, as shown earlier, entropy spreads its effects from the smallest scales of organization to highly complex structures such as the brain. One more thing that is unique to both the scales of life and mind in relation to entropy is evolution. It seems that during big evolutionary jumps, such as the emergence of the cell, then multicellular organisms and now societies, the common factor is the phase transition all scales underwent in order to suppress the chaos. Multicellular organisms are a clear example of how a single cell finds the external world way more unpredictable and disordered than an environment made up of its copies. Same with society, where we surround ourselves with humans, as they are on the same level of organization. As we said, during the evolution of the human mind, There was first entropy expansion, and what we got as a higher cognition from that actually emerged in the process of cooling off the chaos. The system reorganized into something greater than it was before. The psychedelic state is a sample of that primary consciousness that takes place if you rapidly disorganize the brain. And what we actually see is the dissolvement of patterns, but also the creation of new connections. Synesthesia is a commonly reported effect from psychedelics and is described as the entanglement of one or more senses. Seeing the colors of music, smelling the odor of numbers, and seeing time as a sequence of patterns are examples of such phenomena. This state might give a window to pick on what potential states could be entered if the organization of the brain was about to change. So after many years of cooling off the entropy of our brains in order to process the world more efficiently, it is time to move our looks from the past to the future. If the transition between primates and modern humans happened as the result of a rapid entropy expansion and thus more possible mental states, then the abstraction of principles from this transition might give a clue to what stands somewhere further upon. It seems to me the next phase transition that will render the Homo sapiens as old news must occur again after a rapid expansion of chaos. Whatever might cause that change, it will involve the radical change of what we call our brains into a new system. A candidate for this change is the emerging development of neurotechnology. Once we master the communication of the brain with our technology, the possibilities become almost limitless. One might even say the repertoire of mental states becomes elevated. The rapid addition of intelligent parts will drastically disrupt the current organization, not unlike the process of entropy expansion. If the neuroplastic brain manages to adapt to the changes and reorganize again, this time integrating the new parts, something new is going to emerge. Something far different from a biological human brain. The singularity is approaching fast, and it depends on us to decide how important role we will play in it. When culture and technology begin to override what the current organization of the brain offers, we have to either accept our irrelevance for the future, or transcend once again into a species that runs at the top of intelligent evolution.